Alright, so in this video we're going to talk about what to do with negative exponents. There's going to be, just like the last one we talked about when we're doing exponent operations with multiplying and dividing, sometimes you'll be given a negative exponent, or sometimes you'll be multiplying and dividing with exponents and you'll end up with a negative exponent. And you might be wondering, what does that mean? What can I do with that? So what we're going to talk about in this section is how to go back and forth from a negative exponent to not have a negative exponent. Sometimes you like to write it that way because sometimes it's more clear, sometimes it's not. So let's just make sure we know how to go back and forth to know what they mean. If you read what it says at the top, it says any non-zero number to the negative n power is the multiplicative inverse of its nth power. That's a really fancy way of saying 5 to the negative, we'll say negative 2 power. The multiplicative inverse of 5 is 1 over 5. In other words, the reciprocal. So when they say multiplicative inverse, they're also saying the reciprocal. So the reciprocal of 5 is 1 over 5, because remember 5 is technically 5 over 1. So that's saying 1 over 5 to the second power. Now the exponent's positive. When you take that item with a negative exponent and you slide it to the other end of the fraction, meaning technically it's on top of the fraction right now. If it doesn't have one, it's over 1. Now if you slide it to the bottom, that negative exponent now becomes positive. So 5 to the negative 2 power means the same thing as 1 over 5 to the positive 2 power. That's what that rule is saying when they're talking about how to handle the negative exponents. So that's what we're going to do. We're going to do a few examples of that. So now, first take a look at theirs. 4 to the negative 2 power, well, that's like the one we just did. That turns into 1 over 4. So 4 to the negative 2 power turns into 1 over 4 squared. And now the exponent's positive once it's down there. So sometimes it's up to you whether you want your answer to be have a negative exponent or not. I would like for you, for my class, to be able to say both. So if you come up with a negative, tell me that, or what's the equivalent version of it. Or sometimes I'll just actually ask you to convert it. Or I'll say, rewrite it using a positive exponent. I mean, rewrite it in a way to where that exponent is no longer negative. And you do that by getting it on the bottom. If it, by the way, if it was already on the bottom, such as, let's say we had 1 over 4 to the negative 3 power. If you had something like that, if it's already on the bottom and it's negative, when you go to now slide it to the other end of the fraction, it's now going to be on top. 4 to the positive 3 power is now going to be on top. 1 is still up here, but 1 times that just equals that. So no reason to write it. And there's technically a 1 down here. So because there's nothing left down there, it's technically a 1, but anything over 1 is just itself. So we're just going to the answer is 4 to the positive 3 power. That's the opposite way around. Now, please don't think that we're flipping the fractions, because technically when we're doing this, guys, we're only sliding that item that is a negative exponent. For example, take a look at this example I have at the top. I'm going to say x to the negative 2 power, y to the third power. All of that is going to be over z to the negative 4 power. So, and your instructions are to rewrite this using a positive exponent. Well, let's use what I just said. Only the things with the negative exponent get, I call it sliding, but it get moved to the other end of the fraction. So z has a negative exponent, so z's got to be moved to the top. X has a negative exponent, so x needs to be moved to the bottom. It's the equivalent. It's another way of saying the same thing. We're just simplifying. We're not actually solving for anything, again, just like the last video. So z is going to go to the top, and it's going to be positive. And then x is going to come to the bottom, and x is going to be positive once we do that. So that tells us the equivalent version of this is the same thing as saying y to the positive 3 power. Notice y didn't move because it already had a positive exponent. And now next to it's going to be z, but z is going to be to the positive 4 power now. And on the bottom we have x to the positive 2 power. And that's going to be our simplified version for that example I just gave you. Only the items that have the negative exponent, so x and z, they're the only ones that change from top to bottom. And so just remember, it's not flipping the fraction, it is just moving what is negative, what has a negative exponent, it's moving that to the other end of the fraction. So I just want you to realize that. That's what you're doing. Now, there's two ways to go about solving this. I think the way I explain it by just saying moving that negative exponent item, whoever that is, moving to the other end of the fraction, that's a good way of thinking about it. That's always true. Even if you have one number, even if it's in the bottom, you want to move it to the top. Like let's say it says rewrite it using a negative exponent besides -1, because that's kind of boring. If you have 1 over x to the 6th, that's the same thing as just saying move x to the top, but once you do that, the exponent that x had now is negative, so it's just x to the negative 6th power. or doing this. A way to kind of explain is kind of what we talked about. Writing it in a way to where whoever has a negative exponent moves to the other end of the fraction. But if they're wanting you to use negative exponent, you have to kind of take that item and move it to the other end of a fraction. This is in the bottom of the fraction, so when you move it, it's going to be in the top of a fraction. There's nothing left down here when you move it, so there's just a 1 down there. But that's what we know about any number. Anything can always be over 1. We can always make it a fraction. Now, let's take a look at some questions we have at the bottom. Let's take a look at example 3. In example 3, our job is to simplify x to the 4th power times x to the negative 7th power. What we just learned in the previous video is that when you multiply like bases, you add their exponents. Now, you could use that shortcut. It still applies here. It's just negative 7. So you have to do 4 plus negative 7, since those are the exponents. So look down here. Positive 4 plus negative 7. Well, when you add a negative, you technically subtract. So when you subtract, you go to the left. So 4 minus 7, that's going to be negative 3. So that tells us x equal, all that simplifies down to x to the negative 3 power. Now, you can write that as your answer, or you can rewrite this as having a non-negative exponent. So I'm going to say that's your answer, unless it was specific about what they want your answer to be. That, or let's move x to the other end of the fraction so that its exponent is positive. So x is currently in the top of a fraction where it's over 1. So let's move it to the bottom. If we move it to the bottom, there's going to be nothing left up top. So to hold that place, we're going to put a 1 there. So we're going to say 1 over x, and now it's to the positive 3 power. So the left side and the right side mean the exact same thing. And please note, we did not just flip the fraction. I know it looks like it when we only have one thing, but anytime, you can always put a 1 on top or bottom if you need it. It doesn't matter. So if you need to move something to the bottom, the top is a 1. If you need to move something to the top and there's nothing left in the bottom, put a 1 there. So you can have your answer in this format or in this format. And that's using the skills we talked about, which is adding exponents whenever you're multiplying like bases. That's what we talked about in the last video. The visual way to do that, which is technically called using the definition of a power, the visual way to do that is to do this. Write each of these in expanded form. X to the 4th power means x times x times x times x. There's 4 of them. So x to the 4th power is just 4 x's times each other. X to the negative 7th power. Well, that's what we just talked about with moving something to the negative. I'm sorry, moving something to the, if it's negative exponent, moving to the other end of the fractions, moving it to the bottom. So move that to the bottom, but there's got to be 7 of them. So have a fraction where there's 1 on top, since there's nothing left on top, and there's got to be 7 x's in the bottom. That's what we could do. So here, we're multiplying by x's. And down here, we're dividing by x's. Well, think about what we talked about in the last video. When you multiply and divide by the same thing, they cancel each other out. So this times x and this divided by x, they cancel. That's why I see a slash through them. This times x and divided by x cancel. Times and divided by x cancel. Times x and divided by x cancel. So nothing else cancels. We're left with things on top. Now on bottom, we're left with x, x, x on bottom. So that means on the bottom of our fraction, we still have x cubed. So we actually have 1 over x to the 3rd power. And you can leave your answer like that, or you could say the answer is x to the negative 3 power by moving it to the top of the fraction. So this and this mean the same thing, but based on how you write your answer, it's going to be based on how, maybe if there's somehow instructions, and if you're not sure if the instructions don't say, just put it as both ways so we know what you mean. I want to point out, in case you don't realize that these out here cancel with these down here, it's because if you were to multiply these by these, what you would do is you could literally put the left side, here I'll do it up here, put the left side over 1. So when you multiply that, you would have x, 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 x on the top of the fraction times 1, which is just x, 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 x. So 1, 2, 3, 4. You would just have that over all those x's on bottom. So you would still then end up canceling these, canceling these, canceling these, canceling these, and being left with the 3 down here. So you'd still end up being, it would still end up being the same thing. So I just want to know you could save that step just kind of by writing them side by side. So these are some examples of doing some operations with negative exponents. We're going to do a few more, and we're going to we'll do a few more examples of hopefully reviewing how to move a negative exponent to the other end of a fraction, stuff like that. Just that item that has the negative exponent within a term. And then we're going to do some more where we're doing operations between them, where we're going to have to simplify using negative exponents. All right, now I'm going to show you guys an example of doing the same thing, but instead of multiplying by being a product, let's do a quotient or division. Let's do one like that, and let's talk about it. I'll start with one that's given on the screen. Just remember, if you need more help understanding what is the product property of powers and what is the quotient property of powers, please refer to the last video that was made and check out the examples in that one. All right, so in short, the shortcut we learned in the quotient property of powers, meaning when you divide with exponents, if you have like bases, we learned that you subtract the exponents. So because these are both a's, the top and bottom, we're going to take 6 minus 4, and that's going to give us 2, so the answer is a to the second power. So that was an example of working this out and getting your answer that way. Now, and that was simplifying this. So actually, this question doesn't have any negative exponents. There's no reason even to discuss this right now with negative exponents. It's just using the skills of what we did last section. Now, if you want to see the visual of what we did last section, what this question has, you have 6 a's up top, you have 4 a's on the bottom. If you're multiplying by a and dividing by a, those are the opposites of each other. So each pair of them cancels. So these cancel, these cancel, these cancel, these cancel, and you're left with 2 a's on top, which is a times a, which means a squared. So as a reminder, that's the visual way. So this example didn't have negatives, so let's go find one that does. All right, so in each of these examples, you see the bottom, each of these exercises. Let's quickly go through these and we'll take a look at them. I may not do all of them with you, but I'll at least talk them out with you and I'll reveal the answer. So hit pause and try some of these if you think you kind of have an idea of how to do some of them. And pay attention to what we talked about how to move something to the other end of the fraction. 5 to the negative 4th power, the instructions say write it using a positive exponent, meaning we got to move this to the other end of the fraction in order to make that exponent positive. It's currently in the top of its fraction because it's over 1 if you need it to be. So that means in order to move it to the bottom, it's going to go to the bottom and there's going to be nothing left up top, so we're going to put a 1 up top. So when you move it to the bottom, it's going to become positive. So we're left with 1 over 5 to the 4th power, and now the exponent's positive. That is a way to simplify it with a positive exponent. Now number 2, again, all this base negative 6, all of that is the negative 7th power. So that means all of that is going to move to the bottom of its fraction. It's currently in the top, so it'll go to the bottom. If it was in the bottom already, it would then go to the top. So when we move it to the bottom, the exponent's going to be positive 7 now, and the base is going to be the same. It's going to be negative 6. So we're still going to have this. It's going to be 1 over negative 6 to the 7th power. Technically, an odd number exponent means you're going to have this times itself an odd number of times. This is negative 6, so technically if you multiply it by itself an odd number of times, you are still going to have an odd number down here. Technically, if this was negative 6 or negative 4 or just an even number, a negative number raised to an even power is going to result in a positive answer. So questions like that, technically that negative sign is gone because think about it. Negative 2 squared, all of that squared means negative 2 times negative 2. Well, negative times a negative, that's positive 4. So if you had negative 2 to the 4th, you'd have 2 of these that would give you a positive. You'd have 2 more of these which would give you a positive again. So you'd have positive times a positive, which would still give you a positive. So just know if you have an even numbered exponent, a negative base is going to become positive. It is technically true. However, to be picky, you sometimes can leave it. It's not that big of a deal. But I want you to know it is proper to understand that it does become positive. To make a positive exponent, it's in the top of its fraction. Move it to the other bottom so that it has a positive exponent. So you have 1 over a to the 8th power, to the 8th power, excuse me. Now, look at these next instructions. Write each expression using only one negative exponent this time and be creative. Let's make that negative exponent something other than negative 1. So for example, number 16, don't just put that on top and say 16 to the negative 1 power. Be creative. Break up 16 into maybe 4 squared. That might help you do that one. Number 4, to write that with a negative, if we make that exponent negative, we've got to move it to the other end of the fraction. So it's going to go to the top. So that means we're going to have 5 to the negative 3 power over 1, which is just 5 to the negative 3 power. Number 5, to move that one, same exact thing. The x's exponent has got to become negative, so it's going to go to the top and become x to the negative 4th power. Technically over 1 if you want it to be. Now I gave you a hint for number 6. I said for number 16, let's be creative. Instead of saying 16 to the negative 1 power, they said other than negative 1. So 16 is a perfect square. 4 times 4 is 16. So technically on the bottom, we have 4 squared down there. We have 1 over 4 squared. Technically it means the same thing as 16. So to move that to the top, it's going to be 4 to the negative 2 power, 4 to the negative 2 power, or maybe you thought of 2 to the 4th power, and so it could be 2 to the negative 4th power for 16. You could have done that as well. So this or this. Those are 2 ways to write this with a negative exponent. I just came up with one of them. Now down here, simplifying each expression, when you do these, you're going to use the properties we talked about. This is the product property that's multiplying. So you're going to do 6. Remember, you add exponents. So 6 plus negative 5 means 6 minus 5. 6 minus 5 is 1. So that means a to the 1 power. Well, a to the 1 power, that's just a. So that's the answer, number 7. Number 8, you should add exponents whenever you have common bases in your multiplying, just like the last section. Now you just need to use your negative skills. Negative 11 plus negative 12. That means you're going to combine negatives. You're just adding negatives, so you're subtracting. You're going further into the negatives. You're going deeper. So that's going to be negative 13. So you could say into the negative 13 power, or you could write the equivalent and move that to the other end of the fraction so that that exponent can be positive. That would give you 1 over into the positive 13 power. Going on to number 9. Number 9 is not going to use any negative skills. We're just going to subtract our exponents with our like basis. 7 minus 3 is 4, so we have r to the 4th power. So I'll just kind of review what we did last section. So these are some examples of following some of the instructions they're asking us to do, and we're revealing what we need to do in order to solve them, how to simplify them. All right, in these questions at the top, it says the instruction are to write each expression using a negative exponent other than negative 1. So be creative with some of these. Number 9 is going to be just like the ones we talked about before. Move 3 to the other end of the fraction, so it's going to be 3 to the negative 9 power. Questions like number 11 or number 15, you'll notice we don't have any exponents, so we get to maybe make some of our own by perhaps finding a way to write it in a way that helps us get rid of include a negative exponent. Now, there's sometimes some flexibility in how to write some of these, so you might slightly interpret these a little different, or you might do it kind of similar. Number 14, 36 is a perfect square, so technically that's 1 over 6 squared. And now to write that with a negative exponent, we could just move 6 to the top of the fraction, moving it to the other end, by making its exponent negative, and then it's going to be over 1 or just over whatever, so it doesn't matter. So you just say 6 to the negative 2 power. That would be way to number 14. Number 15, I would simplify that fraction first. 2 over 200, that equals 1 over 100. And now you can do what we just did in number 14. Make that 1 over 10 squared. And then now to move 10 squared to the other end and have a negative exponent, you could say 10 to the negative 2 power. That's another way to write number 15. Now for number 11, if we want to get a negative exponent in there, unfortunately 125 is not a perfect square, but we can break it up. We could say the equivalent of that is 1 over, let's say, 25 times 5. We could do that. And then 25 is known as 5 squared. So we could say 1 over 5 squared times 5. So at this point, we've gotten to a point where we're like, okay, we have an exponent, and now we can maybe move that item to the other end of the fraction. And so, oh, that occurs to me. It doesn't have to be a perfect square. Of course, 5 squared times 5, well, that's 5 to the 1 power. That's 5 cubed. I'm silly. All right, so let's just write this as 1 over 5 cubed. That is, I wasn't even thinking about things past squared. It doesn't have to be a perfect square. It can also be a cube. All right, so let's see. 1 over 5 cubed, I said. Okay, so now let's do the same thing. So now to put that 5 in the other end of the fraction, we have to make its exponent negative. So 5 to the negative 3 power, and it's over 1 or just over, don't have to write it. So that's going to be the simplified version of number 11. Okay, now for the rest of these, it's kind of a similar thing. So I just want you to know when you're moving these, just make sure when you move it to the other end, you make the exponent negative. And the rest of those, it's just going to be a really straightforward answer. I just want to do some of the tricky ones on this page. So for example, number 9 is going to be 3 to the negative 9th power. That's the answer, number 9. Okay, so I'll pick and choose some of the questions off of this page just to do a few that I think that are new. I'm not really going to do the ones that are very similar to what we learned last video. For example, I'm not going to do 24. I'm not going to do 26. Those are using things we talked about in the last video. Same thing with 22. At first glance, those seem to be the obvious ones of using skills we learned in the last video where I don't see any negatives. All right, so now number 17, if we multiply those together, we have to add the exponents. So 4 plus negative 5. Well, we could sure work by doing this. 4 plus negative 5. Well, 4 plus negative 5 means 4 minus 5, which is negative 1. So that means we have a to the negative 1 power. You could state that as your answer for number 17, or you could phrase your answer as 1 over a to the 1 power, or just 1 over a, since the 1 power just means a. This or this are equivalent things. They mean the same thing, so you can say this or this. That is fine. Number 19, we're multiplying, so let's add these exponents. We have negative 17 plus negative 19. Using your negative skills, that's negative 16. So that gives us c to the negative 16 power. Let's go ahead and we could write your answer like that, or you can say your answer is moving that to the bottom of the fraction since it's currently in the top. If it's not in a fraction, remember it's currently the top since it's over 1. So move it to the bottom, the top becomes a 1, something's got to hold that place. So c to the positive 16 power. So this or this, they both mean the same thing. Okay, so let's go to some of the ones down towards the bottom. Let's do some division questions. So now, questions like number 23. S to the negative 11 power divided by s to the negative 4 power. In this question, we have a problem where, remember, when you divide, you subtract. So you have negative 11 minus negative 4. So you're going to have to use your negative skills. We have s to the negative 11 minus negative 4 power. So remember, when you minus a negative, you end up adding. So really that says, let's rewrite that, s to the negative 11 plus 4. That's what it's really saying. Use your negative skills back from chapter 1. Negative 11 plus 4 means start heading back towards 0, so you can get negative 7. So that equals s to the negative 7 power. So you can say the answer is s to the negative 7 power, or you can move it to the other end of the fraction. In this case, it'll be towards the bottom to make it a positive exponent. So you can say 1 over s to the positive 7 power. I totally wrote that way too low, as if I was about to write a negative. 1 over s to the positive 7 power. You could write it like that for number 23. Now, let's go on over to number 27. Number 27, if you have coefficients, totally rock them, do them. Show those coefficients what you can do with them. 24 divided by 4, well, that's 6. So we start off with 6 for part of our answer for that one. And then c to the negative 4 divided by c to the negative 2. You have to subtract. Negative 4 minus negative 2. It's just like what just happened in 23. So that means we're going to have negative 4 minus negative 2, which is negative 4 plus positive 2. So negative 4 plus 2. That's how you could kind of show your work like that. So I'm already skipping this step right here. That gives us negative 2, so we have 6 to the negative 2 power. So that is your answer, or move it to the bottom of the fraction since it's currently in the top and say 1 over 6 squared. So you can write it that way. So this way or this way. I'd like for you to get in the habit of writing both ways so you already know that they're equivalent. You're constantly reminding yourself that they're the equivalent. So please have both, because that's going to help you have a more complete understanding of this concept. Number 28, we're going to make our last one on this page. If you start off with the coefficients just like the last one, if you haven't done so already, please press pause and try this question on your own without any help to see if you can do it on your own. 30 divided by 6 is 5. A to the negative 5 divided by a to the negative 9. We have to subtract using the quotient property of powers. Negative 5 minus negative 9. Same thing happens that happened in 23 and 27. When you minus a negative, you end up adding. So let's just write that as negative 5 plus 9. So 5 to the negative 5 plus 9 power. That's what we have to figure out up there. Negative 5 plus 9, that's positive 4. So we have 5 to the positive 4 power. And that's our answer to number 28. It would be silly to say or 1 over 5 to negative 4 power. That would be silly, but you technically can. But that's not going to be necessary. That's a little overkill to always say or, the equivalent. So when we already have a positive exponent, just leave it be and write it that way. So our answer is 5 to the 4th power for number 28. Take some time to reflect on these and see how we're using the product and quotient, so multiplying and dividing rules we talked about in the last video, but now we're combining what to do when you have negative exponents. Okay, we're going to do about 3 word problems at this point. We're going to do the 2 you see on the screen, and we'll do 1 more, and then we're going to call it quits there. Just doing some problems showing you how one of the ways that we can use these things. Alright, so let's take a look at these 2 questions. So in the first one, in number 19, we're going to look to see if there's an error, and if so, let's identify it. And in number 20, we're just going to do a question where I'm showing you an example where we can use negative exponents. For example, when talking about really small quantities, like really small weights, or really small sizes like cells and stuff, when they describe the size of those things, you'll see them using scientific notation usually, but they're also using, we'll talk about that in a later video, but they're also using negative exponents to explain it's really small. It's a really small fraction, so it's really less than 1. Okay, so number 19. It says Lorenzo needed to find what is 1/9 of 27. His friend Carla told him to write 1/9 as 3 to the negative 2 power and 27 as 3 to the 3rd power, and then multiply those 2 together to get 3 to the negative 6. Was Carla correct and explain? Now, technically, when you get 1/9 of something, anytime you do a fraction of something or a percent of something or a decimal of something, in math that means multiply. You would do 1/9 times 27. So she is correct when she says multiply those two things together. Now, 1/9 of something just really means divide by 9, so I know that you could get the answer to this easily, but that's not the point. They want to know, is she correct in how she's describing how to go about this question? And technically, ladies and gentlemen, what she's talking about here is a way to solve any of these types of questions where it's fractions of stuff. Yeah, you can convert them all to exponents like this, just make sure you convert them correctly, and go through these questions and do them that way if maybe you want to avoid some of the fraction stuff. However, that is easiest when one of your numbers is a 1 in your fraction, but it does still work even when it's not. Take your time, and I think you might enjoy the challenge. Well, as long as there's a common base you can use. All right, so let's first check her original assumptions. Let's make sure she converted these correctly. So we're going to check her original assumptions. And this is something that you would do when checking your work if you didn't know if it was correct or not, or if someone told you it was wrong but they didn't tell you where. You should go back to your base assumptions to make sure those things are correct. Okay, so 1/9 as a exponent. Like we mentioned earlier, writing it with a negative exponent, 9 is a perfect square, or it can be found by doing 3 to the second power. So that's just like saying 1 over 3 squared. Now, to make this a negative exponent, to move this to the top of our fraction, we can make that positive exponent to a negative exponent. So that becomes 3 to the negative 2 power. That means the same thing as 1 over 3 squared, or same thing as this. So 3 to the negative 2 power is indeed the same thing as 1 over 9. So Carla is correct about that first conversion. Let's check her second conversion. Her second conversion is 20. She says change 27 to 3 to the third power. 3 to the third power. That means 3 times 3, which is 9, times 3, which is 27. Oh, so that does check out. So 3 to the third power is indeed 27. And by the way, Carla did it this way because she saw that she could make this base of 3, make this base of 3, and that's the whole point of using exponent properties, is when you have like bases, common bases, in order to use the properties of them. Okay, now she said multiply this by this. We now know that she's converted these correctly, and we already mentioned earlier, when you have a fraction of something or a percent of something, that means multiply, a piece of something. It means to multiply in math. So now it says to get, so far so good. Now it says to get 3 to the negative 6 power. Was she correct? So we know her base assumptions were correct in how to convert. We know that she's supposed to multiply, so we're with her on there. Now let's just see if it actually does equal 3 to the negative 6 power. That's what we're now checking. So 3 to the negative 2 power times 3 to the positive 3 power. When you multiply with common bases, we learned you add the exponents. You add them. So that means negative 2 plus 3. Negative 2 plus 3, that equals positive 1. So that tells us we have 3 to the positive 1 power. If you have an exponent of 1, don't bother writing it. It's just the number, it's just the base. So the answer is 3. She said it was 3 to the negative 6 power, so it turns out Carla was incorrect. So, and intuitively, whenever I said 1/9 of something, yeah, it means divide by 9. 27 divided by 9, that is 3. So you knew the answer to this question already, but this is a way to show you how you can also, if you didn't know the answer or it was a more complicated answer, maybe it was a fraction answer, you could have found out your exponent skills. So let's see. To explain our reasoning, we're going to have to say Carla's base assumptions on how to convert was correct. She converted these perfectly, and Carla was correct about multiplying to find our answer. Unfortunately, Carla's mistake was in her actual operations doing it. She made a mistake. She looks like she multiplied her exponents by each other, and you don't multiply exponents by each other. That's something you'll do maybe a little more in Algebra 1 as well. When you only multiply exponents, as a side note, when you have a power of a power. That's not happening here. So keep these questions simple, so we don't need to multiply these exponents. So she mistakenly multiplied those exponents, negative 2 and 3, to get negative 6. That was her mistake, when she should have added the exponents to get positive 1, which means they're not really needed. So the answer is 3. So that's how Carla was correct most of the way, but she made one mistake at the very end. I'm pretty impressed that she did those conversions correctly, though. That means she's pretty good at negative exponents, but she maybe needs to review on how to do what we learned in the last video about the product property of exponents. It's good to find people's errors. Use that to help yourself. Use that to help your friends. But use it in a positive way. Use it in a constructive criticism way to help people improve and learn from their mistakes, especially if it's your own mistakes. Okay, let's take a look at number 20. If you think you've got number 20, press pause and try number 20 on your own first. All right, number 20 is about rice. Read it yourself as I read it out loud if you haven't done so already. The mass of a grain of rice is about 10 to the negative 2 power grams. About how many grains of rice are in a container holding 10 to the 4th power grams of rice? So in this question, we know how heavy one of them is. It's 10 to the negative 2 grams. Now let's just make sure we appreciate that fully. 10 to the negative 2 grams. That tells us 1 over 10 squared, which equals 1 over 100. So that means 1 grain of rice is 1/100th of a gram. 1/100th of a gram. So if you want to use your decimal skills, yeah, 1 out of 100 is going to be 0.01. So that's telling us this much of a gram is how much 1 grain of rice is. Remember, a gram is a unit of measures, of weight, of mass. So yes, you can turn this into a decimal. That's not what we're talking about right now. And yes, you can turn this into a fraction. But right now, we're not talking about fraction skills, so we're not doing it that way either. So I want you to realize, even knowing that it's this way, I wanted you to see what it means. We're going to most likely leave it how it is and just do the operation that we need to do. But I want to make sure you understood what it meant for something to be given on purpose like that, because it's a mouthful sometimes to say, what if it was like a piece of DNA, or was it a cell or an atom in science class, where they are extremely small. So this number could be to the negative very, very large power. And so you can have a very scary looking fraction if you try to do that on your own. So mathematically, it makes more sense to just leave it as an exponent that you can use, even if it's negative. All right, about how many grains of rice are in a container holding 10 to the 4th grams of rice? Well, this question sounds kind of scary maybe. Let's simplify it. Let's make this a really easy question. Let's say you're dealing with marbles. Each marble weighs 1 ounce, and you're told that your container is 12 ounces. How many marbles are in your container? So if your container is 12 ounces and each marble is 1 ounce, you would do the 12 ounces divided by 1 ounce per marble, and you would find out that there would be 12 marbles roughly in that container. That's what they're asking us to do here. So what we just revealed, this is a division question if you didn't realize it already. To solve this question, we're going to divide. I just wanted to make a similar type of question to simplify it, where you could see, let's not use scary numbers, but let's talk about it and see, oh, this is a division question in order to solve this. That's a problem solving skill. So now we're going to use that to actually answer this question. We know how heavy one of them is. We know how big the entire container is. The entire container divided by how heavy one of them is, that's going to help us find out how many of them are in there. So that means we're going to have 10 to the 4th power divided by 10 to the negative 2 power. That's what that tells us. Now to answer the question, we just simply have to show our work and find out what this equals. When you divide with like bases, you subtract exponents. 4 minus negative 2. It's like some problems we did earlier. When you minus negative, you add. So this really becomes 4 plus positive 2. So we have 10 to the 4 plus 2 power, which is to the 6th power. So 10 to the 6th power. That's what that tells us. That's how many grains of rice are in this container. 10 to the 6th power grains of rice. Now, that might not be an answer you fully can appreciate how big that number is. That might not mean a lot to you. So let's actually expand that. Let's do 10 times 10 times 10 times 10 times 10 times 10 times 10. I think that was 6, I hope. And see what that equals. But I'll give you a hint. If this is a 10, whatever this number is, that's how many, because remember, 10 times 10 is just add a 0. That's how many zeros you're going to have. You're going to have 6 zeros. So let's write this out. 1 with 6 zeros. 1, 2, 3, 4, 5, 6. There are some commas in there. Oh man, that is 1 million grains of rice. That is how many grains of rice are in this container that weighs 10 to the 4th power grams. There are 10 grains of rice. And help you understand that, 10 to the 4th power, that's just 1 with 4 zeros on the end of it, so that's 10,000. So this is 10,000 grams of rice. So you've now answered the question though. This is the exponent answer. And your homework solutions may sometimes say this, but let's be precise and let's make sure we're clear what we're talking about. You're not walk up to someone and say, there's 10 to the 6th power. They're gonna be like, 10 to the 6th power what? You're gonna say, oh, 10 to the 6th power grains of rice. Oh, let's be specific. Let's give them a number that they can appreciate. When you're trying to sometimes really explain the size of something, it might help to write it this way and say 1 million grains of rice. That might help people understand these types of questions and be able to talk it out. This is a counting skill to estimate how many grains of rice are in your container. Okay, so make sure you take a moment to think about that and have appreciation for the truly small size of the grain of rice and how many grains of rice can fit in a container that weighs that much. We're gonna do a question just like that, but I'm gonna let you try it on your own, then I'm gonna give you the answer. All right, press pause and give this question a shot on your own and see if you can take what we just did and apply it and do it successfully yourself on this question. See if you can do the same thing. All right, this is that awkward silence where you better hit pause and try this question on your own. All right, so let's see. Read it to yourself if you haven't done so already. The mass of a grain of salt is about 10 to the negative 4 gram. Okay, that's the mass of 1 grain. Okay, about how many grains of salt are in a shaker containing 10 to the 3rd grams? So that's grams is a weight. That's not grains. Grains is they're counting, like 1 grain of sand or 1 grain of salt. And then grams is a unit of measure for weight or mass. So they're saying this is how heavy one of them is, this is how heavy all of them are in the container. So how many of them? So just like the last question, we're going to divide to solve this question. We have the total weight. We're going to divide it by how heavy 1 grain of rice is. So now mathematically go through your steps, use your quotient property of powers, of exponents, and keep track of anything you have to do with negatives, and answer this question, simplify it, just like we did in the last one. When you divide with like bases, you subtract the exponents. 3 minus negative 4, so 10 to the 3 minus negative 4 power. Minusing a negative becomes adding a positive, so that becomes 10 to the 3 plus 4 power, which is 7. So we have 10 to the 7th power. That's the answer for how many grains of salt are inside of this container. Now, to give appreciation to the person you're saying the answer to, let's give them appreciation for how many grains of salt that really is. So like we said earlier, 10 times itself 7 times is essentially going to be 1 with 7 zeros on the end of it. 1, 2, 3, 4, 5, 6, 7. Now let's throw some commas in there. So that tells us thousands, this is hundreds, this is thousands, this is millions. So we have 10 million. So that tells us inside of this container there are 10 million grains of salt. So sometimes that can be a lot to write or a lot to say out loud. And that's one of the reasons why we talk about making these using exponent rules to help us calculate them or help us describe them, like when they talk about the weight of one of them. So that helps you kind of get perspective of how this is working. So there's 10 million grains of salt in this container. This was just an example of solving a real world problem using things that we have about negative exponents. Make sure you practice these and notice how a lot of these questions in this section are very, very similar and almost some exactly the same as what we did in the last section using the power properties of multiplying and dividing. So just take your time and know how to do equivalents with negative exponents and you'll be just fine. You'll be ready to simplify.